Hello, welcome to today's class. Here we'll be looking at integration by parts and I'll be solving more examples on it. Okay, now by definition, we're told that if u and v are two functions of x, then the integral of u and v is equal to u integral v dx minus the integral of the derivative of u times the integral of v, all with respect to what? X. That's the standard definition of what? Integration. So how do you integration by parts? How do you identify that this particular question falls on integration by part? When other methods cannot work and two or more functions are multiplying each other, the fact that two or more functions are multiplying each other, then there's tendency that what? Integration by part will surely work. Now, to break down this definition to layman understanding, I can say that let u equals to the first function and v should be equal to the second function. Okay, so according to what is here, I can say that since u is the first one, v is the second one. So you are writing your v, meaning write the first function, multiply it with the integral of the second function minus the integral of the derivative of the first function times the integral of the second function But don't forget, this integral here is affecting everything that is here. So everything here will be the integral of everything here with respect to what? X. Here you get. Okay. But better still, using the general definition, we can say that the integral of u dv is equal to uv minus integral v du. How do you arrive at this? If this is the first function, and this is the second function, u, it means you are writing your first function. V, how do you get v from the v? Meaning you integrate to have this. Then it means you are integrating your second function minus the integral of v. What is v? The integral of your second function du and the derivative of your first function, which is still the same thing as what is here. So that is what the definition of integration. But with time, you will get used to it. So better still, since you guys are familiar with this, you can make use of this definition. But this is the standard definition of integration by part. Now let's solve questions using it, and let's look into some rules guiding your integration by part. Okay. Now let's start with the first example. The first question says that the integral of x exponential 3x dx. Okay, now I can say let this one, the x, to be what? My u, and the exponential should be my what? V. Okay, now using the definition, we can make use of this definition. And what is the definition? The definition says that you write your u, you integrate your dv, that's the second function. You write the first function. What is the first function? That's u. So you integrate the second function minus the integral of, you integrate the second function, then differentiate the first function. So applying that definition, I can say that, okay, what are those things I really need? I'll need to differentiate my u. So from if u is equal to x, if I differentiate it, du will give us 1. And then if dv is equal to exponential 3x, if I integrate dv, it's going to give me what we call v. And when I integrate exponential 3x, that will give us 1 over 3 exponential 3x. Now, since I've gotten u du, dv, and v, I can substitute it into this what formula by saying the question is equal to uv minus the integral of v du, which is the same thing as, what is u? U is x, that's x. What is v? V is times 1 over 3 exponential 3x minus the integral of v. What is v? 1 over 3 exponential 3x times du. What is du? 1 times 1. So is equal to 1 over 3x exponential 3x minus this 1 over 3 is a constant, so I can bring it out by saying is the same thing as 1 over 3 the integral of exponential 3x. Now at this point I have to integrate this. Okay, so on integrating that, I have my final answer to be 1 over 3 x exponential 3x minus 1 over 3 times, if we integrate exponential 3x, that's 1 over 3 exponential 3x. So I have it to be times 1 over 3 exponential 3x. Therefore, my final answer to that question, integral x exponential 3x, is equal to 1 over 3x exponential 3x minus 1 over 9 exponential 3x. Final answer plus C. Okay, so that's what we call integration by part. Okay, but there are some questions on integration by part that it's occur, like you apply, we call it iteration. You apply integration by part more than once. That is, you apply the formula like twice, 3 times, depending on how strong the question is or depending on the look of the question you get. Okay, now let's try to look into another example. What if we have a question like this? The integral of x squared sine x dx. Okay, now simplifying this, I can say that let this x squared to be the first function and this should be the second function. Okay, applying the formula says that uv minus integral v du, right? So meaning you write the first one, integrate the second one, minus the integral of integrate the second one, differentiate the first one. Okay, so now let's apply that. Okay, now write the first one, that's x squared. Integrate the second one, integrate sine x. Okay, minus the integral, let me write that in red, minus this integral, minus the integral of v. What is v? V means I'm integrating the second one. That's the integral of the second one, and the second one is what? Sine x. That's the integral of what? Sine x times the derivative of the first one, which is what? X squared. So I have that to be x squared. If I integrate sine x, that's minus cos x, minus the integral of, if I integrate this sine x, I have minus cos x, and if I differentiate this, I have 2x. Okay, which is the same thing as minus x squared cos x. If I'm to bring this minus outside, this minus here, bringing it out, it turns to what? Plus, because minus times minus is what? Plus. That's plus. This 2 is a constant, so that will give us plus 2 the integral of x cos x. Okay, now at this point I should say this is my answer, but there's integral sign in it, so it means I still have to integrate that part. Now integrating this part, I realize it is integration by part again because it involves two functions multiplying each other. So I can call this the first one and I call this the what? The second one. Okay, now integrating that, we can say our answer, which is this part, the initial question is the integral of x squared sine x dx, and is equal to minus x squared cos x plus 2 into bracket. Why is it into bracket? Because we want to solve this using integration by part. Now applying integration by part on this alone, where this is the first function, this is the second function, using the formula, write the first function x, integrate the second function. If I integrate cos x, that will give us sine x minus the integral of, integrate the second function, sine x, differentiate the first function. If I differentiate x, I have it to be what? 1. Okay, so let's close the bracket. Now at this point, we can open the bracket. Opening the bracket, we have it to be minus x squared cos x plus, the 2 is affecting everything inside the bracket, so 2 times this, I have to be 2x sine x, and then minus 2 integral sine x. Okay, so now let's remove this final integral. Removing this, we have it to be, that is, we are going to integrate sine x. Now when you integrate sine x, it's going to give us minus cos x. So I have it to be minus x squared cos x plus 2x sine x minus 2 times the integral of sine x is minus cos x. And my final answer is now equal to minus x squared cos x plus 2 sine x plus 2 cos x. Final answer. So there are situations whereby you can apply integration by parts to a question more than 2 times, 3 times, depending on the type of question you are dealing with. Okay, but there is a problem. The problem is, how do you identify? I said let x squared be the first function, let sine x be the second function. How do you just assume this should be the first function, this should be the second function? No, we have a rule guiding that, and we'll be looking at that in our next video. So we'll be looking at rules to figure out your first function and second function. Then we solve more questions on integration by part. Thank you.